So, hello, good afternoon. Here it is. Bit lower. Well, let's talk about OpenLI. I don't know if there are any people here with a legal background, perhaps. Great, at least one. This is a topic where most people, I guess, don't like to talk about. The introduction, thank you. Got a bit in that direction. Tapping of internet, lawful intercepts is not something we want to talk about, except for this person and myself. But you're still here, so let's see what's on this topic. Yeah, it's on the screen. I have some abbreviations here. You can read it through if you don't know what it means, like law enforcement agency, etc. In the presentation, I use a couple of abbreviations that are non-technical, and perhaps you don't know what they are. But it is in three items. What are the obligations network operators and service providers have? And what is the OpenLI software? And can we use it here in the Netherlands as an alternative? That are the topics for today. And the Lawful intercept for ISPs came from, well, around 2001. And I'm in this topic as well from that time. So more than 20 years of experience with the Lawful intercept. And this is from the telecommunications law that all providers, service providers and network operators must have their network tappable if they have public services. That's mandatory, you have to do it. So I guess that most of you have somewhere in the network something like this. The other article was very important, that you have to cooperate if there's a warrant. And a warrant can be from the police or for the intelligence agencies, for instance. And you have to execute it. And there are some side effects, what you need to do as a provider around this topic of intercept. And you must have your network tappable. That's one thing. But you also have to make it secure if you have to deal with warrants, because it's a high-risk thing. It's about investigating, it's about criminals, etc. So you have to need your security measures. They're in the BBGT directive. What you also need to have is a sealed connection. And the sealed is the Dutch word Centraal Opsporingspunt Informatiepunt Opsporing Telecom. So this is the place where all the subscriber data is put from every service provider in the Netherlands in one single database where the investigators, police, intelligence agencies can look at the subscriber data plus the IP address, telephone numbers, etc. With the security measures also comes that you need an NDA and a code of conduct for the personnel that's involved with these lawful intercept. And you also need to have a security plan and a continuity plan. Also from the privacy directive in the law. And this is how it is in the Netherlands for this taps of the internet traffic. The provider must make the intercept possible. So the provider is doing the work, must have something in place, and then in real time it is sent over to the police, where it's gathered together and then sent to the investigator that needs this traffic. This needs to fulfill the specifications that are mandatory here in the Netherlands. That's published in the Staatscourant, so the governmental newspaper, which standards you need to fulfill. That's the ETSI standard today, the TS 102-232. The standard is divided in several parts, part 1 up to part 7. And the part 1 has to deal with the handover of the warrant and the data. And the other part is how to intercept the specific traffic and how which fields and elements are necessary to hand over. The intercepted data is placed in a payload, and this payload is surrounded with a header, and this header must fulfill with the ETSI standard. And this is a European standard, also used in Australia and New Zealand. We'll come to it later on, why this is important. And in the standard is also room for national implementations. So the Dutch implementation of the ETSI standard is in the ETSI IPNL standard. So not all countries use the same things in the standard. There are options. One option, for instance, is that we in the Netherlands have the payload encrypted. Most countries don't. Well, the first part is talking about 3 handover interfaces. The handover interface 1 is about handling the warrant itself. So this is something that goes from the police to the service provider or the network operator. This can be in 2 ways here. That can be by email. That's for the smaller ISPs, the most used interface. And it can be with something that's called the message broker. And that's something the larger network operators are using. Then we have the HI2 interface. That's the handover of the intercept-related information. So that's the metadata of the intercept. And this is something saying who is connected to who, at what moment, and how long does this connect last. So for telephony calls, these are the CDRs, for instance. And the HI3 is the actual data itself. So the internet traffic, or the phone call, or the email message. The HI2 and the HI3, oh, I see a typo. HI2 and the HI3 interfaces, they are encrypted, the payload, and the header that is surrounded to fulfill for the ETSI standard is an ASN1 header. And also the transport, so the handover itself is encrypted. So it's double encrypted. And it's a good thing, encrypted transport and encrypted data. Something you should always do, by the way. Well, the situation here now, for a long time, we actually tried in 2001 to start a working group for making software in open source. I don't know if anyone here still does know about it. No. There was a working group for open source software for the intercept. Problem here is that it's not a fancy topic to make open source intercept software. So we had a working group, and it died very soon with a couple of meetings, and no one was willing to invest their own time to make this kind of software, and there was no employer willing to contribute. So we ended up in using off-the-shelf software from a couple of vendors, but they are expensive, and very expensive. And what I saw lately was that from the New Zealand network operator group, so it's a group just like we are here now, had to deal with the same thing. If we want to do Lawful Intercept, it costs you a lot of money. And the question there was, can we make some software together to solve this issue of the money? In the Netherlands, we did it in another way. But there was the initiative to start making software. It was handed over to the Waikato University, to the WANT research group. And they already had some libraries for dealing with network traffic. So the libtrace library. So they already knew how to deal with network traffic. And well, that's all from the website, by the way, from the OpenLI.nz website. Today there are 13 companies contributing the money to fund this project. And I believe there was also some project money when they started a few years ago. So this software was built, and it's in use in the New Zealand country for the ISPs to fulfill to the Lawful Intercept requirements over there. It is open source. And what I told you before, in Australia and New Zealand, they also like to use the ETSI standard, European standard. They are more focused on Europe than on the other countries of Asia, I believe. They are also in the Eurovision Song Contest, etc. So there's some bond with Europe, and they comply to the ETSI standards we use. Here's also the TS 101671. That is the previous standard that was used for the PSTN and ISDN services. But that's now incorporated to the TS 101232 standard. Just recently, I think, in the beginning of this year, the project was handed over from the university, because the university cannot do the support, cannot commit to support for years. So they transferred the support to Searchlight. So the developers of the software are now in a separate company, Searchlight. And they exist from support contracts. So if you like to use the software and use it, well, that's a good thing to have a support contract as well, to make it possible that this software is still developed. They support the part 1, part 3, part 5, part 7 is on the website. But I believe they also support part 6. And they do support VoIP, voice over IP. And I'm not sure in which part it is. But they say 1, 3, 5, or 7. And for ISPs, that are all the parts that's needed. So IP traffic, VoIP, and email. The email just recently, by the way. There are 3 elements this software is using. That's the collector, the mediator, and the provisioner. And there's a 4th element. I will come to it later on. But there are 3 key elements in the software. And the collector is the part that is collecting the data, that's filtering, and that's encrypting the data, and then sent over to the mediator. The mediator is receiving the captured data and send it to the law enforcement agency, so to the police in the Netherlands. And the provisioner is providing the configuration to the collector and the mediator. So that's a management function of this infrastructure. And the major work is done by the collector. That makes sense. That is filtering, capturing, encrypting in our situation, and sending. So this is best to have this in a separate hardware. the more data you need to intercept, the more encryption you need to do, the more CPU power you need, network cards, and memory for buffering situations. It depends on the size of your network, what you need for this hardware, but best to do it in separate hardware. The mediator and the provisioner can be on the same system, and that can be done on virtual systems easily. Well, it's built on Linux systems. We run it on Ubuntu, but you can also run it on other Linux flavors. It's built in C. The other PIM told you about the DPDK, so I don't have to explain. But filtering with DPDK and XTP, hopefully in the future is possible. I've experienced with pre-filtering for intercepts with XTP, and it's a similar idea that bypassing the kernel and filter directly in the network interface driver, or offload it to the network card. So you don't need the CPU to be involved with filtering. That's possible. So it's possible to have a line rate on 100 gig, for instance. We need to test how far we can go, but it should be possible with pre-filtering. The project's on GitHub, so anybody can download it. Installation is pretty easy. Can you find here? It's using the bash scripts they provide on the GitHub page. And they download the necessary libraries and other packages, and have the package installed for the OpenLI software. And there are 3 components in the script: the collector, the mediator, and the provisioner. So you can choose on which system you install whatever. The software is using a REST API for configuration. The configuration, the initial configuration is in the config files, and YAML files. But all things you can adapt by the REST API. And the REST API elements are exactly the same as in the config file. So if you read the config file, I will show you in a minute. If you read the config file, you exactly know how you can call the REST API calls. There is a web interface nowadays, but I've not used it yet. We're working on this software for a couple of months now to test and to try if it's working here. Never used the web interface, because what's interesting in our situation is that we have an administrative system for handling with the warrants, all kind of warrants, by the way. And then we can make a call to the intercept infrastructure with the REST API, but also monitoring and analyzing what's going on can be done with tools like Prometheus, Grafana, whatever. So we can integrate this whole intercept infrastructure with the normal day-to-day network monitoring and handling procedures. And with the REST API, you can make this possible. Well, I don't know, is it readable? This is a working configuration of in 2 pages of the complete intercept infrastructure, and make it possible to test. On the 3rd page or 4th, I don't know. I will show you how to test this. And if you start with the collector, so that's the intercept system itself, you need to configure what the provisioner is. And then you have an operator ID. That's something that's from the standards. An element ID, so that's the location where this intercept system is placed. If you have multiple systems in one location, then you need an intercept point ID, and then some other configurations that are possible. It's also possible to connect with the RabbitMQ system, and that you can use for buffering in case there's a network glitch. And, well, which interface is used for intercepting. Then the mediator configuration is also not very hard to read. Same operator ID, if it's in the same network, of course. The mediator, the configuration of the mediator, which provisioner you like to use, that you need to do. And if you like to store intercepts locally, then you need the PCAP directory, and there's a configuration if you want to send it to the LEA or if you want to store it locally. And also here it's possible to use the RabbitMQ for buffering. And the provisioner is even worse with the configuration. It's very easy to install this. The client address is its own address. The mediator, well, the mediator in this example is on the same system, so it's the same IP address. The update address, I'm not sure. And then the intercept itself, which intercepts need to be installed. And that you can have an intercept in the configuration, but in production it's not very useful because you would like to install intercepts with the REST API interface. And for the REST API, you of course can use the OAuth authentication mechanism. So you need the provider, the REST API key, authorization key, and you can configure this in the provisioner. And the intercepts, you can have multiple types of intercepts, VoIP, IP, email, and several flavors. So you can install the VoIP servers or the email servers in the intercept. And you also need to give the LEA configuration here with the intercept on for which end station do you install this intercept. In the Netherlands we use one gateway for the government, but well, there will be situations in other countries where you have multiple LEAs for different intercepts. So you can configure it here, and you can also configure if the IRI and the content of communication, the data itself, must be on different systems or on the same system. Well, here we use the same system, so the IP addresses and port numbers are the same. And that's it for configuring intercepts. Not very hard. And the REST API, well, you need to create authentication keys, of course. That's here. There's a script for it to do this. And then here's some examples of the REST API calls. If you're used to work with REST APIs, then it should look very familiar. The agency, here's an example for looking which agencies there are. So the LEAs, the LEMF, the monitoring facilities, the tapping chambers, how you call it. But here it's called the agency, and you can look at it, and you can add one. And the outcome of the first call, getting the agency, and the JSON file you need to create a new one is exactly the same. So you see an example here on the right of a JSON file. But if you do this first call, you get the same thing on your screen. So the agency ID, the HI2, the HI3 address and port numbers, the keep alive frequency and the weight, that is something that is specified in the national implementation of the ETSI standard. So that is something you get from the government, these two settings. And then you have the put command to put a new agency in. In this case, I've added two addresses, the same address as the local host address. You can see this, I hope. And that you can use, and that's the fourth part, for testing. You can create a local LEA on a system. It can be on the same system as the mediator, but you can also use a different system. So you can use a local LEA with the trace packet dump program. And the trace packet dump can be used for multiple kinds of traffic, but also for the Etsy LI traffic. And that's with Etsy Live keyword of the Etsy file keyword. So you can have a stream of traffic, and that's what you set up in this previous example here. And then if there's an intercept, it will be streamed to the localhost port number 41002 or 3. And with the trace packet dump, you can act as a receiver of this traffic and act as if you are a LEA. And then you can output of the trace packet dump you get on the screen, where I can save it on file, of course, and then you can see if the flow is what you expect. And it looks a bit like this. It should be underneath each other, but then it doesn't fit. But this is an example of a trace packet dump packet. So it's a header. It always starts with PS-PDU, and then a PS header and a payload. And they're with all kind of elements that are part of the header and the payload. You see, for instance, the operator identifier, country, but you also see here the data type. On the right, for instance, this is an IRI message, so it's not a payload. And the encrypted payload type is part 1, so this is probably an HR1 something. And you can then follow the trace, what's going on with the intercept, and if it's looking good or not. That's about the OpenLI software. Half a minute left. One page. And does it work? Key question, does it work here in the Netherlands? Because it's a New Zealand software, a piece of software. Yes, it does. We're working for a couple of months on it now, and testing and trying. What was missing, the major part that was missing was the encrypted payload. But they're pretty eager to bring the software to Europe as well. So the encrypted payload is implemented now in the latest version. But what do you need to do to use the software? Well, you need to have a connection with the police. That can be on IXPs here in the Netherlands. And you need to direct peering with the central organization. They need to be able to get the warrants from the police, from INS. That can be by email or by the message broker. But I can tell you the message broker is not an option for most of you. I guess one here perhaps, but the email is with PGP, the pretty good privacy for encrypting the warrant. You need to have an operator ID, contact the RDI for this, and then test with the police to make this happen. You have to install the software, of course, one machine if you're a smaller network, and a virtual machine, and this should get you up and running. Questions?
Thank you, Pim. And now, if there are any questions, then be sure to phrase them such that you don't give any information away. Are there any questions? There is one, the infamous Peter Lexis.
Hello. Yeah, I had a question. You mentioned that the payload encryption happens here in the Netherlands. How is the key communicated? Is it in a warrant, or how does it work?
Very good question. Well, the warrant for Intercept is actually a XML file. And the XML file is standardized here in the Netherlands. That's part of the ETSI-NL. It will be part of the ETSI standard itself. And that's something we call the ESUB HI1 interface. I had it on the screen, but I didn't mention it. Here the email ESUB HI1 interface. That is a standard way of handing over the warrant. So it has a couple of fields in this HI1, in this XML file, and also the warrant itself is embedded as a PDF in this XML file. And in this XML file is also the encryption key for the payload. So handling of this XML file must be very secure. That answers the question? Yes. Okay, great.
All right. Well, thank you again, Pim. We have a token of our appreciation for you.
Thank you.